Welcome to the Real Python Podcast. This is episode 275. What are the steps to get started building a FastAPI application? What are the different types of concurrency available in Python? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We discuss a recent Real Python step-by-step tutorial about programming an example FastAPI application. You practice installing FastAPI, building your first endpoints, adding path and query parameters, and validating endpoints using Pydantic. Christopher covers updates to his Real Python video course about concurrency in Python. The course digs into what concurrency means in Python and why you might want to incorporate it in your code. He describes the different methods and demonstrates how to approach coding using threading, asyncio, and multiprocessing. We also share several other articles and projects from the Python community, including a news roundup, the PSF Fundraiser campaign for 2025, where Python stores attributes, performance hacks for faster Python code, a project to transform functions into a web interface, and a Python disk-based cache. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher. Welcome back.
Hey there.
All right. Actually, got quite a bit of news to start this week.
Yep.
Unlike last time. Got a couple announcements from different organizations, a bunch of topics that are wildly interrelated, and of course our projects. So you ready to dig in?
Yeah, let's do it.
All right. So what do you got first?
Yeah, so as you mentioned, a bunch of news starting out here. I'm going to begin with some Django items. First off, there was a security release giving us Django 5.2.8, 5.1.14, and 4.2.26. This release covers two problems: a potential denial of service vulnerability for HTTP response redirect on Windows, and a potential SQL injection bug on query set objects. Normally, I don't mention this, but both of these vulnerabilities have CVE numbers. CVE is short for Common Vulnerability Exposure. These are public IDs given to a security issue which helps researchers coordinate and track problems in the field. For example, the HTTP response redirect vulnerability that I just mentioned is officially CVE 2025-64-458. Or Bob to its friends. CVE numbers are assigned by a CVE number authority, which in the wonderful world of nested acronyms shortens to CNA. And there's a central organization that can assign these numbers. As well, there are certain orgs that are allowed to issue their own. You might recall that the Python Software Foundation became a CNA 2 years ago. And all of this leads me to my second bit of Django news. Django is now a CNA, which means their next release can issue their own numbers. The announcement came out a couple days before this release, so I'm not sure if they issued this number or not. I couldn't figure that out, but it's happening soon, if not on this one itself.
Cool.
Well, on the topic of Django, one quick non-news item. In PyCoders, we linked to Carlton Gibson's article that proposed that Django should switch to an annual release cycle. If you're curious as to why he thinks that, we'll link to the show notes. I think I'm with him. I think I like the idea, but I'll let other people argue about that. Next up is PEP news. We've already spoken about PEP 8.10. That's the one proposing lazy imports. It got accepted, and it looks like this language change will be coming in Python 3.15. So this time next year, we'll be talking about it again.
All right.
Last year, the Python Software Foundation Board of Directors started holding office hours once a month, an opportunity for you to talk to them. Sometimes they cover topics and other times they just take questions. But if you want to know more about the PSF and the board and how things are going, you can attend one of these sessions. Recently, they released the schedule for the remainder of this year and all of next year. The next one past the release of this podcast would be December 9th at 9 p.m. Universal Time. They even moved the time around to accommodate different time zones. So if that's too early or too late for you, maybe pick the January one, which is at a different time of the day. The link in the show notes has the full schedule for 2026. That seems weird to me. 2026 sounds like far off in the future, not a month and a half from now. I've been seeing ads for the Running Man movie remake. It turns out the original book was written in 1982 and was set in 2025. So in 1982, 2025 seemed like way in the future. And for those who aren't familiar with the book, it's about a dystopian time where the economy is in bad shape, AI is used to fake news, and television and media control politics. Glad it didn't turn out that way in reality.
Yeah. Phew.
Speaking of 2026, my last bit of news is next year's PyCon US. It will be hosted in Long Beach, California, and runs from May 13th through the 19th. The call for proposals is now out. You have until December 19th to submit, and there's a maximum of 3 submissions per person. I'm already seeing lots of back and forth on Blue Sky about, people submitting or starting to submitting or procrastinating about submitting. So This is getting talked about. So,
yeah.
And you've got something?
Yeah. The PSF, the Python Software Foundation, the people that host the PyCon US and other PyCons across the globe, they've started their 2025 year-end fundraiser. Earlier this year, they were hit pretty hard with travel to the US for PyCon for reasons. And then the last month has been rough with a particular funding grant. I'll share a link to their blog post about recent events. They have a blog post that's titled Connecting the Dots, Understanding the PSF's Current Financial Outlook, which explains a lot of it and all the different things that they do. And it's a really good piece explaining some of the situation going on. One of the things I really like about the PSF is they're very transparent about this stuff. They're very good about communicating what's going on and telling the community the situations of behind a lot of this stuff. And this year, I really want to call out the fundraiser. The PSF is a charitable organization. It's got a mission to promote, protect, and advance the Python programming language, and to support and facilitate the growth of this international community of Python programmers. They have this fundraiser. And so a great way to keep it going and this community strong is to go to donate.python.org, where you can donate, become a member, learn more about Python community, and you can also follow along how the fundraiser is going. They want to note that the PSF only wants you to donate if you are in a position to do so. Sharing this information, sharing the PSF's donation page on social media posts, things like that help a lot too. So make sure to check out the social media accounts and subscribe. I will include links for that. And something I've brought up in the show in the past, but I want to stress this year, corporate sponsorships are crucial. If your employer uses Python to build products and services and is yet to be a PSF sponsor, share the PSF sponsorship and the prospectus page with your organization. So again, you can donate, spread the word, help the PSF hit their fundraising goal, and work together to help ensure that the Python community is supported and Python remains free forever for everyone.
A lot of large companies will match sponsorship donations as well. So if you happen to work for those kinds of companies, this is a great way to sort of double down on any kind of donation you make. In case you're curious, anytime sort of fundraising stuff comes up, you often sort of what do they do with this, right? Like, well, what we're doing is we're buying, gold fixtures for Guido, and no, that's not what this is about at all. Very, very few Python folks are actually paid for what they do, and the money goes to help support building CPython itself. PyPI costs money. Yeah. Every time you do pip install, you're burning server hours, right? So these things cost money to maintain. And it's sponsorships that help deal with this kind of stuff. Quickly releasing security patches, having people who work on this stuff, all of that stuff costs time and money. And, Python's a giant ecosystem and there's a huge amount of support behind it. And these guys are actually getting by on a shoestring budget. Like, I'm confident that the owners of other languages that are corporate are spending way more than the PSF gets from any of this.
Yeah.
So it's a good thing to do. And if we all chip in just a little bit, it gets us a little further along as a community.
Yeah, absolutely. I mean, something we mentioned on the show, I've brought a lot of these people on, is that they have brought on some full-time employees. And honestly, I think it's a good portion of what has helped the language itself and the Python package index move things forward and become more responsive in a lot of ways. So working on that has been paid through the PSF also. All right, well, we're going to dig into topics here. The first one I have is a real Python piece. It's from Philip Exeni. The title says most of it, a close look at a FastAPI example application. FastAPI, as we've noted on multiple surveys over the last couple of years, is a very popular framework for building across the web. In this particular case, you'll be creating a FastAPI example application. You'll build like a randomizing API that shuffles lists, picks random items, and generates random numbers. It's one of our step-by-step tutorials, so you'll follow along. And just a note, you should be comfortable defining Python functions, working with decorators, and have a basic understanding of CRUD. That's one of Chris's favorite words.
My favorite computer acronym, definitely, by far.
Yeah, and JSON. So if you aren't, I'll have a link for a much more fundamental FastAPI tutorial, and also some other links across Real Python where you can learn some more of these topics. In this particular case, you'll be creating a virtual environment and installing FastAPI into it. And this is actually one of the first of many intricacies. For the tutorial, when you go to pip install, you need to specify what you want in your particular install of FastAPI. The framework itself, in this case, but you also want to have this thing called an ASGI, an ASGI, asynchronous server gateway interface. And in this case, it's using a package called Uvicorn, which can be included. You just have to specify that. So when you go to pip install, you type FastAPI, and then in square brackets have the word standard. There's a variety of other ones, as you could probably guess from it being called standard there. One odd thing, depending on your terminal, you do need to have that whole thing in quotes sometimes, because square brackets sometimes may behave differently in different terminal environments. Just be aware of that. And putting things in quotes like that actually saves any kind of issues that you might run into.
Especially Mac, because ZSH doesn't like them. They're meaningful.
Yeah. You start by creating your first API endpoint. That's by setting up this basic program of importing FastAPI, creating an instance. In this case, you're going to use a common convention of app equals FastAPI, creating that instance of a class. And then you use this decorator style used by many of the frameworks now of the @ symbol app.get. And then in parentheses, you'll have in quotation marks / for your home, the root URL of the API. And then you run that, make sure everything is working in your browser. This is actually one of the first time of many that you will visit the documentation, which uses a tool called Swagger. And there's also another tool that I wasn't familiar with. I haven't used FastAPI in a little while, but there's a thing called Redoc, which has been added as part of the Open API standard. And you can see this Swagger UI and go in and interact with it. You go to this default URL, which would be, again, running on your local machine. So localhost is 127.0.0.1:8000. And then in this case, if you add a /docs, that brings up the Swagger UI, and that's where you can kind of see and interact with it. There's also now a new one where you can do /redoc, REDOC. The Swagger UI provides an interactive interface. It lets you kind of test the endpoints directly from the browser. And then Redoc is a more of an organized read-only view of the API. Through this, you kind of continue enhancing the API endpoints, declaring path and query parameters. And this is where you dive into types. And this is truly one of the areas in Python development where type checking really shines. As you iterate through these steps, you'll be going back and forth from the code and looking at things and running them in the browser using Swagger and testing the API functions. And you get to start to practice more of the underlying features that are coming from a tool called Pydantic. And Pydantic provides data validation using Python type hints, ensures that the data your API receives matches your expectations before your endpoint function even runs. It makes for really clean code and drives much of the automated documentation I was just speaking about. It also makes it a lot more descriptive. You use these Pydantic models to define the structure of the request bodies and validate the models. And Phillips takes you through that. And then he leads you into, remember Uvicorn I mentioned earlier, you do a little bit of handling asynchronous requests. So you update your code leveraging async and await keywords. Now your API can handle multiple requests concurrently without blocking. So the next section digs into managing security with CORS, C-O-R-S, cross-origin resource sharing. This controls which domains can access your API. Without a proper CORS configuration, your browser will block cross-origin requests from JavaScript applications by default. And that'll prevent access from your API from different domains. So it's a common issue when your front end and your API are hosted separately. So you get to practice it a little bit here. In the end, you tidy up things a little bit of refactoring, cleaning up the structure of the documentation using metadata tags, straightening out how everything will look. Thanks for the step-by-step tour, Philip. And again, if you haven't explored FastAPI at all or would like a more thorough introduction, Philip's got a tutorial also, and it's just get started with FastAPI, and I'll include a link for that too. You've been using FastAPI at all?
I use it occasionally. I've taught with it a couple times. Usually when I'm teaching like web access things, having FastAPI on the back end for like a quick little web server. And I've done it when I was playing around with something like Docker or whatever, and I was trying to figure out what the rules are for accessing stuff, whipping together a really quick, I can hit this URL and it'll behave like a web server and make, figure all that kind of stuff out. But being the author of Django in Action,
yes.
I tend to default to the other platform if I'm doing anything big. So I do use it for sort of experimental stuff, but it's not like I've hosted sites on it or anything.
Yeah. All right. Speaking of asynchronous stuff here.
Yeah, I don't know how it happened. We do seem to have a bit of a theme running through the show, and it was mostly accidental, so that's fine. And what Mr. Bailey is referring to there is recently at Real Python, we did a revamp of one of my older courses called Speed Up Python with Concurrency. The course was 5 years old, and things have changed a bit in Python and concurrency since then. The course covers threading, async I/O, and multiprocessing, and then has a light smattering of things like the GIL and sub-interpreters just to sort of give you an idea of what is still ongoing work in Python. At a really high level, there are two kinds of concurrency, I/O bound and CPU bound. Let's talk about I/O bound for a bit. Your processor spends a lot of time waiting for things. It's actually kind of hard to wrap your head around the scale of the difference. To try to hit that home in the course, I cover a distance analogy. So instead of time, think of distance. Let's equate a single CPU instruction, that's about 0.01 nanoseconds, depending on your processor, et cetera, your mileage may vary. Let's call that single CPU instruction about a meter, which is close enough for the purposes of what we're talking about to a yard. If you're not good at visualizing a meter, that's about the height of a doorknob off of the floor. There we are. 1 meter, that's one instruction. Referencing memory takes about 100 nanoseconds. That's many orders of magnitude bigger than a single CPU instruction, meaning tons of processor stuff can get done in that same time. So back to our distance analogy, if one instruction is the height of a doorknob, then a memory reference is about 10 kilometers or 6 miles. And that's just a reference. Actually, fetching content is worse. So if you're grabbing 1 megabyte from memory, that would be another 30 times that, as in 300 kilometers or 186 miles, about 3 times the length of the Suez Canal. And that's still within your machine. When you start doing things on the network, it just gets crazy. A typical ping time from US to Europe is around 150 milliseconds. Note that we've gone from fractions of a nanosecond to hundreds of milliseconds, or 15 million kilometers. That's about 1/10 the distance to the sun. Let's say you were taking a casual stroll at about 1 meter per second, and each pace you had was a CPU instruction. Well, you'd be walking for 475 years before that packet got back from Europe. And that pretty much defines I/O-bound concurrency. It's a way of getting your CPU to do something else while it's waiting for all of that stuff. Are you loading a web page? Well, while you're waiting for the network, you can do the processing to start the load of another web page. The threading and async I/O libraries both provide ways of doing this. Threading hasn't changed all that much. but asyncio has. So one of the reasons for the course revamp was to modernize that content. And of course, there's the GIL, which is a global lock in the interpreter. And that also gets in the way of how threads and asyncio works and sort of mucks with your speed up. And this is something else that's actively changing in Python. So this gets talked about in the course. If instead you're doing CPU intensive computations like, say, math, where all the time is spent on the processor, threading won't do you much good because there's no waiting to take advantage of, which leads to the other kind of concurrency, which is using multiple processors. In Python, you do this through the multiprocessing library. So the course covers these two kinds of concurrency, when you should use each, which libraries you can use to implement them, the challenges in using these libraries, like things like deadlock and race conditions, and has loads of examples along the way. I had fun building this the first time around, and it was kind of nice in a sort of nostalgic way to go back and polish it up and see what's changed for the re-release as well.
Yeah, it's definitely a popular topic. It's something that comes up all the time as far as like, well, how does this actually work? And I think the analogies help quite a bit.
Yeah, well, and even over like the last 5 years, not that it was hard to get a multiprocessor machine 5 years ago, but it's almost impossible to get a single processor one now, right? Like the dirt cheap stuff has multiple processors in it. So if you want to learn how to take advantage of that and when you can and when you can't, and that, that's what it's for.
Yeah, totally. All right. So my next one is another piece from Trey Hunter, who we featured recently also. It's titled Dunder Dict, Where Python Stores Attributes. So that's 2 underscores DICT and 2 underscores. When you make an instance of a class, it has attributes. I thought of an example, like let's say you have products for an online store. Let's say you sell t-shirts. You create an instance of the shirt class, and it has attributes for the t-shirt, the design, the price, and the size. And so you would normally access them with dot notation. So you'd be like shirt.design and equals this, and shirt.price equals, and shirt.size equals, whatever the letter is for the size. So there are 3 attributes, but where are the actual values stored for that class? The class has an instance of this Dunder Dict attribute, which you can access. And it's a dictionary that's in that. So if you typed in shirt._dict_, you'd get this dictionary. You'd see all the different attributes and their values inside there. If you wanted to, you could modify this dictionary directly to change the attributes. And he shows in the article going through that process, but it's really not something you should do. In fact, it's a pretty common clue here. If something has underscores, it's usually not intended for you to be adjusting directly from that. It's something that's intended to be kind of under the covers or hidden a bit. But he wants to sort of just explain this concept of like, okay, well, where is that information truly stored when you create these classes? You should always use dot notation, or the particular case if you're constructing a new instance, the parameters when you're creating that instance. Python's modules also use Dunder Dict attribute to store their data. In fact, he shows this Dunder Dict attribute for the math module, so math.dunderdict. And it's a rather large dictionary that comes back with things like tan and then : built-in function tan, or factorial : built-in function factorial. So each of the functions is stored inside of this Dunder Dict attribute. Along with those functions, as you get down there, it also includes constants for like pi or e or tau, and you'll see those values included there. He also shows that there is a built-in vars function. I haven't used this one very much, but if you type vars and then as you call it, in my case, you bring up the shirt, it would actually return that Dunder Dict dictionary for the particular object. So you would see, again, the price and the size and the type of shirt. He wraps up by showing that not all objects in Python have a Dunder Dict attribute, though everything in Python is an object. Not all use the dictionary to store attributes like integers. So if you bring up like an integer, you won't see that there. Most of the built-in classes don't use one, and it has to do with memory optimization and trying to make Python be faster. This is some of the complaints people have about Python, is sometimes the heaviness of things, like even a single underscore character as a string has all of these methods and all these other things that are attached with it. So he mentions this idea that you can make your own classes be more optimized the way that the built-in ones in Python might by using the dunder slots attribute. And I'll include a link to a piece that covers that concept, but slots are a much more efficient as far as memory optimization way of managing that stuff. He shows one other related built-in function. This is one that I have used more, especially when I'm trying to teach somebody or understand what's going on with object-oriented stuff inside of Python. It's the dir, which shows both the attributes that live on the object and the attributes that live on that object's class. So it's like all the dunder methods and so forth. So you'd see, you might have heard us before talk about dunder string or the dunder repr. So all those attributes are inside there. So dir is a nice way to kind of explore that stuff. I think this stuff is really great when you're trying to learn about OOP in Python, and these built-in functions like vars or dir will really help you understand visually what's happening under the hood and where all this stuff is stored. Again, another nice tour from Trey. Thanks again.
New listeners are going to wonder what the heck that sound effect was. It's been a while since we've used it.
Okay. Yeah, we have not hit the everything in Python is an object thing, but that is our our keyword there.
Beat it to death.
So, yeah. All right. It's time to shine a spotlight on another Real Python video course. It covers a Python feature that powers a lot of the magic hidden under the language's hood, and it's related to one of the topics we covered this week. The course is titled Python Descriptors. It's based on a Real Python tutorial by David Mastro Mateo, and the video course is presented by Stephen Loyens. And he takes you through what Python descriptors are, where they're used in Python's internals, how to implement your own descriptors, and when to use Python descriptors in your code. I think it's a good investment of your time to learn more about object-oriented programming in Python, to learn how classes and their instances behave and discover the kinds of use cases for descriptors within your code. Like most of the video courses on Real Python, the course is broken into easily consumable sections, and where needed, you get code examples for the techniques shown. All our lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. So what do you got next here?
My next article is by Dido Grigorov. AI told me how to pronounce that, Dido, so if I'm butchering it, I'm sorry. Blame the LLMs. The article's title is 10 Smart Performance Hacks for Faster Python Code, and it's a guest post on the PyCharm blog. The title pretty much covers it. There are 10 sections, each covering different things you can do that might speed up your code. The first pointer is about knowing when to use sets in Python. If you're doing a lot of membership lookup, lists are actually fairly expensive, and you'd be surprised how often the order of things really isn't important in your code. And if the order isn't important, you can get away with using a set, and that might boost your lookup performance. Pointer number 2 is to avoid unnecessary copies. This seems like an duh kind of suggestion, but when you're not thinking about it, it's more common to end up with copies of containers than you might think. In-place edits can be several orders of magnitude faster than a copy and edit, and this often pops up if you're a data science person, since most data frame libraries do the opposite and they copy everything, which is fine. They're optimized for that, but if you take the same approach in native Python code, you might be slowing things down. In fact, I ran into this recently with one of my libraries. There was a need to copy, and so I just by default deep copied everything, and it bogged it down horribly. And then I figured out, no, wait, I only really need to deep copy 1 in 10 of these things, so an easy performance boost for me was not to do the other 9. I'll cover one more of the topics from the article, and then I'll let you discover the rest for yourself. The last one I want to talk about is the iter tools module. It has functions like product, permutations, and combinations, and they're all highly efficient. Sometimes switching to a functional programming paradigm can mean a lot of speed up, especially if you're converting a plain Python loop into a composable, iterable approach. And that kind of stuff can lead you towards things like parallelism, which talks about both speed up and concurrency. The other performance hints are when to use the math module, dunder slots, which you just mentioned, pre-allocating memory for certain data types, avoiding exception handlers in some cases, using local functions in tight loops, the bisect module, and avoiding repeated functions inside of tight loops. There are also a couple bonus hints here that are specific to PyCharm about how you can use it to refactor some of your code when you're running into these kinds of situations. So, all in all, some good advice. If you need to do performance tuning on your code, Dido's article is definitely worth checking out.
All right. Well, that takes us right into projects. My project this week, it's titled FuncToWeb, FuncToweb. Transform Python functions into a web interface. So it's by Beltran Offeral. Explaining the title here, it's a minimal boilerplate web apps from Python functions. Think type hints, arrow, web UI. Within like 5 lines of code running this function, you have a simple web page. In fact, lines from FuncToWeb, import run, def divide a : int, comma, b : int, return a / b. So it's basically creating a divide function, and then you run it, and then you would open up your local host and you can see it running in there. One note, Safari doesn't like this thing at all. I don't know why. It just shows up as like a blank page, but Firefox and Chrome were pretty happy with it. I immediately thought of these kind of like, we've talked about having simple tools that you might run in an office. What is it? Shadow IT, we called it. So my wife has worked in mortgages for a long time. So I could think of like having like a really nice little mortgage calculator that, again, has lots of these little functions. The thing I was surprised by in the interface is that when you bring up numbers in it, it has increment and decrement buttons. So you can kind of adjust the values on the fly right in there to tweak things, giving you your team like GUIs from just pure functions. Quick utilities. He actually has a bunch of examples inside the repository on GitHub. Things for like doing image resizing or conversion of files or data transformation, file upload and download. Quick ways to get stuff going. Under the hood, it uses our friend FastAPI I mentioned earlier, and Unicorn, Pydantic, Jinja 2, which is a nice tool for doing templating of web stuff, and then something I wasn't familiar with, Python multipart. If you're doing stuff with images, you're going to want to have Pillow installed, Matplotlib and Pandas and NumPy if you're going to do some of the data science examples. Yeah, I thought it was a really nice tool to get going very quickly. Minimal boilerplate to just throw something up into a web interface and give somebody a GUI to work with. Again, you could host it off a local type of thing, or I guess you could find other ways to kind of host it again using Unicorn there.
Yeah, this is like a great idea for, like those kinds of 1 or 2 liners that as a programmer, you just, you open up Python or you open up the REPL and go, yeah, okay, there's my 2-liner and I solved the problem. This putting a web interface on that allows the rest of the people in your office to have access to that exact same thing, even though they don't know the Python stuff at all. So yeah, it's neat to have this kind of thing.
Cool. What do you got?
We're big fans of the Bytecode newsletter and blog here at the show, and a recent post introduced me to a library that I thought was worth sharing. The library is called Diskcache. It's by Grant Jenks, and it's another one of those name tells it all kind of libraries. Diskcache is like Memcache or Redis. It's a name value pair storage, but instead of being memory-based, it's file-based. To use it, you create an object passing in the file name of where the storage will be. Then you use setters and getters or a dictionary-style syntax to insert and access keys. The library is built on top of SQLite, which means it's thread-safe and atomic, and the storage mechanism is obviously rock solid because SQLite is used everywhere. Now, since it's on disk, you're going to pay a bit of a performance penalty in comparison to memory, but disk is cheap and significantly larger than memory, so there are places where this is useful. You also don't need a separate service running, which some of the popular caches require other things going on in the background. This is just call the library. Documentation is pretty robust and includes a great comparison table between it and other storage mechanisms, helping you to see why you might pick one over the other. So if you're computing something that's expensive, caching it can be a big performance gain, and kind of keeping with our theme of speed up, this library is worth checking out.
All right. Well, I just want to mention a note about the upcoming holidays here. There's going to be a couple gaps in our schedule over the next couple weeks. There's some travel and other things happening in our schedule, so be aware of that. But a bunch of interesting guests coming up. So I'm excited to share those with you. Thanks again for coming on the show, Chris, and bringing all these articles and projects this week.
Thanks for having me.
I want to thank Christopher Trudeau for coming back on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.